Hi everybody, here we are at week 2 and we have a few more lessons for you, or I have a few more lessons for you for week 2. The first one that I have attached is called Sketching Polynomial Functions by Intercepts. So we're going to have a look at that one today, and then I've got a second lesson coming out as well. That'll be well, it's all attached here, I guess. So you go through these lessons at your own pace. Anyways, here is the graph down below that shows the function f of x. And right away I notice that f of x has a leading coefficient of -4/9. Negative is important. It has factors of x plus 3, x plus 1 squared, and 2x minus 3. If you wanted to sketch the graph using pencil and paper, which features of the graph do you think you might want to know? Well, here's a good list of things you might want to know in order to figure out what the shape of this graph might be. You would want to know the X intercepts, so the order on them as well. When we see x plus 3, there's nothing else here. The exponent is 1. That means it's order 1. There's one of those roots. Here, x plus 1 is squared. That's order 2 on the x plus 1. So we want to know that for sure. We'd like to know the degree of the function. Here the degree is x times x squared times x. That's x to the 4, so degree 4. There's certain things that degree 4 do, functions do, and we got into that last week. We want to know the end behavior of a 4th degree or even function. We'd want to know the sign of the leading coefficient, and we know that it's negative. That helps us determine the end behavior as well. We want to know if there's any y-intercepts. Can there be more than one y-intercept for a polynomial function? I'll let you think about that. And we definitely want to know what the factored form of this equation was. Well, we're lucky because it gave it to us in factored form. And I want you to point this out to you right away. See how there's a root at -3? Well, notice that there's an x-intercept here at -3. There is a root at -1, but it's order 2. Here is a root of -1, but order 2. That makes it a critical point. It doesn't pass cleanly through that x-intercept. It hits that x-intercept and bounces back. It creates what's called a critical point. And then there's another one here at 3/2, 1.5, right over here. There's an x-intercept there as well, but that's order 1 as well. Notice how it passes cleanly through. Okay, so if we were to take that equation and we were asked to sketch it, in order to sketch it, sketching is different than graphing. Graphing is exact, sketching is close, it's approximate. So we want to get as close to the answer as possible. So that we kind of know what this graph is doing. If I ask you to graph something, I want it to be a lot more exact, just so you know. So sketching the function, whenever we sketch, we just want to get a general idea of what's happening. So as we discussed before, here's some things we know. The degree is 4, because x times x squared times x is x to the 4, so degree 4. The leading coefficient, LC for short, is negative. That tells me that because it's degree 4 and the leading coefficient is negative, this graph must open down instead of opening up. If it opened up, the leading coefficient would be positive. In factored form, here it is. I didn't have to do any work there. That's great. It's already factored for me. That tells me that the x-intercepts are at -3. That's from this factor, this root. There's another one at x equals -1, but I'm going to write underneath order 2, which means it's a critical point, and another one at x equals 3/2 or 1.5. To find a y-intercept for any graph, don't care what it is, you let x equal 0. So in the original equation, we're going to let x equal 0 and solve. And it looks like when we solve all of this, we get y equals 4. So we have a y-intercept at 4. And that matches the graph above as well, which is great. Behavior for a degree 4 leading coefficient being negative, opening down as x approaches infinity. End behavior, I mean, y approaches negative infinity, it's opening down, like I said up here. As x approaches negative infinity, y would approach negative infinity as well. You saw a couple of questions like that on your quiz just recently. This chart is what's called a sign chart, and I'll explain it briefly for you. What you want to do for a sign chart is take all of the factors that you found up here and write them down the left side. So here's -4/9 is a factor, x plus 3 is a factor, x plus 1 squared, don't forget the squared, is a factor, and 2x minus 3 is a factor. So we've written all the factors down, and then what we're going to do is on a number line across the top, we are going to write all of the roots, or the x-intercepts that we calculated. There's one at -3, -1, and 3/2. So you'll notice that I've separated this number line up into -3, -1, and 3/2. Next, what we're going to do is we're going to take testing numbers that fall either below or between these x-intercepts. And we're going to test each one of these factors to see what the sign would be. For example, here is an x-intercept of -3. My tester that I chose was just one number less, -4. You can choose anything you want. You can choose -10, -100, you pick. It doesn't matter. I just chose a number that was pretty close, but just beside -3 to the left. So if my x value was -4, -4/9, well, that's always going to be negative because there's no x value to change that. So that will be negative. What if x was -4 here? Well, this factor would end up being -4 plus 3, which is a negative number. That's -1, but it's negative. That's the important part. The sign is negative. Here, -4 plus 1 is -3, but squared makes it positive because you multiply two negatives together, you get a positive. In fact, for this factor here, because we're squaring all of our numbers that are inside the bracket, notice how they're all positive right across. It doesn't matter what number I put in here, that answer will always be positive. Then we get to our last factor, 2x minus 3. Well, 2 times -4 is -8, minus 3 is -11. That sign is negative. What do I do now? I multiply the signs together to see what the overall or total sign would be for -4. Negative times a negative times a positive times a negative, well, that's an odd number of negatives. That makes the entire sign negative for that round. Let's do it one more time. I'm going to pick a number between these two x-intercepts next. I'm going to pick -2. And I'll do this a little quicker. -4/9, negative. -2 plus 3 is positive. This we said was going to be positive. And -4 minus 3 is definitely negative. When I multiply my signs together, I get a negative times a negative times a positive times a positive. Well, all together, that's a positive. When I say positive, what I really mean is the graph is positive. The y values would be positive. Or the graph is above the x-intercept. Here, this negative means y values are negative, or the graph is below the x-intercept, or the x-axis. I'm not going to go through these two. You can figure them out yourself. But my testers here were 1 and 8. And I tested the signs of each, and I found the graph is above here and below there. So putting all of this together now, in order to graph this, the first thing I would do is to plot those x-intercepts. Here they are, at -3, at -1, and at 3/2. So I plotted those 3 points. I also plotted my y-intercept at y equals 4, right here. That helps me out with determining behavior. Now, we already decided that this opens down, so this graph would not approach -3 from the top, it would approach -3 from the bottom. And that makes sense because anything left of -3, the graph is below. That's what this negative means. And here's the part of the graph that's below the x-axis. What happens between -3 and -1? The graph is plus, or above, right? Right here. And then again, above, so that means this must be a critical point. We knew that though because it was order 2. The graph is going to approach that point, hit it, and then rebound back up again. That's why it stays positive or above the x-axis. Through our y-intercept, maybe a little higher, and then heads back down to 3/2. And what happens after 3/2? Well, now the graph is below. That's this negative, so there's the section that it falls below. And all of these things are painting a picture as to what's happening with this graph and how to sketch it. On the next page, you'll see what happens when we sketch some different types of functions.